These are the force problems. How do you know they're force problems? So if you see masses in there, you don't need any kind of, or weight. You don't need mass, you don't need weight to do just kinematics. And this, oops, sorry, I've stapled this funny. The way this test is going to be laid out, you're going to have a kinematics problem first. You can count on it. And then you're going to have some force problems. And then there will be one at the very end that's got a little bit of both. But we see one that's got weights and forces and things like that. This is a force problem. And for forces, the primary formulas that you'll need are net force equals ma. That's Newton's second law. And you'll need weight equals mg. You'll also need to have g memorized. G is 9.8. I think I might just tell people that because I didn't tell you to memorize it. And the other thing you're going to need is the definition of net force. This is one way to get net force. The other way to get the net force is to add up all the forces. It's the vector sum of the forces. And the way to solve these problems is to write two equations for net force. Write ma, and then write the sum of the forces, and then set those two things equal because they're the same, and then you can solve for stuff. So that's what I'm going to do here. In this one, we've got this rocket. It's just touched the ground. It says there are three forces acting on the rocket. So right away, I can write an equation for net force. I just need to add up the three forces. There's this one, and there's this one, and there's this one. The weight, I think I did this a little later, but weight is mg, and I can plug in the mass, which is given 0.204, and multiply that by 9.8, and that'll give me the weight. So here's one of my equations for net force. Net force is positive 5.6 plus 1 minus weight. So this is positive because it's up. This is the normal force. This is the perpendicular force of the ground pushing up on the rocket as the rocket falls and hits the ground. Pushes back. This is the force of drag. This is air resistance pushing up. It's the force of this fluid, which is air, pushing up on the parachute mostly. So those are both positive. That's why I do positive 5.6 plus positive 1. But then weight is pulling the rocket down, so I need to do negative whatever this is. That's the net force. The other way to get the net force, the easiest way, is to use Newton's second law. That's the formula that you're given. So the net force is ma. Whatever the mass is, 0.204 times the acceleration. I'm looking for the acceleration. So I get those formulas and then I set them equal. ma is here, and this is here. So I've added 5.6 plus 1. That gives me 6.6 minus mg. I'm just substituting in mg for weight. So there's my equation. Now I'm plugging stuff in. The mass is 2.04. The acceleration I don't know. This force is 6.6. This mass again is 0.204. And g is 9.8. So multiply these together, subtract them from 6, and then whatever that is, divide both sides of this equation by 0.204, and you get a is 22.6-ish meters per second squared. And it's positive, and it's really good for an acceleration, which is a vector, to give magnitude and direction. Number 4, same kind of problem. Just a little different, but you solve it the same way. Notice I've got F equals ma, and then F equals the sum of some forces. But first, part A. It asked me for the mass of the bass, and it tells me that the bass weighs 24 newtons. And it's hanging from a scale, but the scale reads 30 newtons, and there's nothing wrong with the scale. The reason that it reads that is the person's jiggling the scale, causing the bass to accelerate. So back to the weight is 24 newtons. I can use the weight formula, weight equals mass times g, to find the mass. 24 newtons, that's the weight. And mass is what I'm looking for. G is 9.8. So divide both sides by 9.8, we get 2.45 kilograms. That's the mass of the bass. Now the second part, if I want to find acceleration, just trust that on all these force problems, you probably need to do this. I can write an equation for net force this way and this way, and then I set them equal. So mass times acceleration, that's net force. And this bass has two forces acting on it. There's the scale pulling up. I'm going to call that tension. And it says the scale reads 30 newtons, so that must be 30 newtons of tension. And then there's the weight of the bass pulling down. So tension minus weight. So now I've set MA equal to tension minus weight. Plugging stuff in, the mass is 2.5 kilograms. Acceleration, I don't know, but I'm looking for it. Tension is 30. The weight is 24. So 30 minus 24 is 6. 6 equals 2.5 times A. So 6 divided by 2.5 is A, and that's 2.4 meters per second squared upward. I know it's upward because it's positive, and because that makes sense. If this is reading something heavier than the bass's weight, you must be yanking up on the bass. If that were lighter than the bass's weight, you must be lowering the bass down.